Late June 2012. Across the eastern United States, people were sweating bullets because of an intense heat wave caused by a stagnant weather pattern. A dominant high pressure in the southern United States, with a stalled frontal boundary set across the northeast towards the plains, led to numerous excessive heat warnings south of the front, with temperatures in excess of 100 degrees Fahrenheit. To many in the Midwest and Mid-Atlantic states, they would take anything in order to minimize the sweltering temperatures. A breeze or some rain at the least, but what Mother Nature had in store for those areas was way different than what most were expecting. Mother Nature's plan was to print the term derecho into the general public's mind, with the 2012 Ring of FIre Derecho. On June 29th, a progressive derecho swept across the Midwest, Appalachian Mountains, and Mid-Atlantic. The storm complex started off as part of an unorganized cluster of thunderstorms in Iowa and Illinois, and beyond what many would have thought, that cluster expanded into one of the most well-known derechos in the United States. Over the course of 12 hours, the thunderstorm complex produced large swaths of severe wind damage across numerous states, with wind gusts exceeding 100 miles per hour in some areas. The roaring winds outside was nothing like what many across the river valley and the mid-Atlantic had experienced, and during a day that started off as a slight risk for severe weather. The 2012 derecho is one of the most infamous derechos in US history, and I think it's warranted to cover it. Today, I'll be covering the background of the event, the synopsis, the timeline of events, the aftermath, and the significance of the event. Welcome to Nature's Fury. When most think of the Ring of Fire, many think of earthquakes and volcanoes, or Johnny Cash. However, it's also relevant to meteorology. The name, not the term in seismology or Johnny Cash. The Ring of Fire refers to a specific severe weather setup involving a dominant, strong high-pressure system and ridge located in the southern United States. That high-pressure system pushes warm air towards the ground in combination with summertime heating, creating a heat dome. Those underneath the heat dome are subject to extreme temperatures reaching well in excess of 100 degrees Fahrenheit. In the atmosphere, strong high-pressure systems are usually pushed out by strong frontal systems. In the case of Ring of Fire setups, the high pressure can stall out for multiple days due to a lack of Canadian cold fronts and weak winds in the jet stream. Along the edge of the high-pressure system is where the Ring of Fire lies. Because of the hot temperatures associated with the high-pressure system, alongside high dew points, the atmosphere is incredibly unstable and is full of energy along the edges of the system. Storms can grow upscale into large severe storm systems if there is decent mid-level flow observed along the ridge itself, and assuming the storms can break through the cap. More recently, on June 29, 2023, a derecho occurred in a Ring of Fire setup in Illinois. Ring of Fire derechos aren't uncommon, but the 2012 derecho is more well known not only for its unusual synopsis, but also for where it hit. But real quick, most people who like these videos are not subscribed to the channel. If you enjoy my content, please consider subscribing. It helps the channel and tells me I'm doing something right. Anyways, back to the 2012 derecho. Starting on June 20th, a high-pressure system and strong mid to upper-level ridge centered over Baja California shifted northward into the Four Quarters states. The high pressure was stalled over the plains for multiple days, breaking hundreds of temperature records from Colorado to portions of Canada. The high-pressure system and the ridge moved eastward over the next week. By the end of the month, the ridge was still present, located over the southeastern United States. To the north, a broad but strong mid to upper-level trough was over Canada. Embedded within the trough was a shortwave trough moving from Ontario to Quebec, tightening the height gradient and leading to seasonably strong mid-level flow across the Great Lakes. On the surface, a stationary front spanned from southern Iowa to central Pennsylvania. South of the front, a very warm air mass was in place, with temperatures in the upper 70s and low 80s at sunrise. The expectation was that storms could fire in Iowa, and potentially move across the Ohio River Valley and into the mid-Atlantic. But the threat was noted as conditional early on. To those who saw my video on the December 15th, 2021 derecho, it may seem odd that these ingredients led to one of the deadlier derechos in US history, but that's because the 2012 derecho was not like what was observed on December 15th. In fact, it was a different type of derecho. What happened on December 15th was a serial derecho, which is usually associated with an extensive squall line, or QLCS, with multiple individual bow echoes that form a series of scallop-shaped structures known as line echo wave patterns, or loops. Serial derechos usually form in association with well-organized low-pressure systems and a strong mid to upper-level trough. Strong wind shear and low to mid tropospheric flow are the main source for the intense winds at the surface. The motion of serial derechos is dominated by advection, the downstream movement of individual thunderstorm cells by the environmental winds, and they travel parallel to the mean wind direction, which is the main difference. Serial derechos are often easier to forecast because the primary forcing mechanisms responsible for their development are fairly well sampled by today's observing network. Progressive derechos are different. Progressive derechos are often much smaller in scale and are not associated with strong and well-defined low pressure and trough systems. Instead, progressive derechos form along stalled frontal boundaries, with the MCS traveling perpendicular to the mean wind direction. The motion is dominated by thunderstorm propagation, the development of new storm cells downstream from existing ones. According to the National Weather Service, low to mid tropospheric flow in the neighborhood of progressive systems is typically not strong, suggesting that, in contrast to serial type events, the intense surface winds observed result more from storm-induced downdrafts than from the downward transfer of fast mid-tropospheric flow. In fact, too much mid to low level flow can prevent progressive derechos from occurring, like what happened on a predicted but ultimately non-existent derecho on June 14, 2023. The wind shear was too strong and kept cells discrete, preventing upscale growth. So what do progressive derechos rely on in order to form and thrive with little forcing nearby? Extreme instability with high cape and high lapse rates, while still needing some mid-level flow in order to continue moving forward. Progressive derechos are extremely difficult to forecast because they arise in relatively benign large-scale environments with little to no identifiable atmospheric forcing. So with the differences between a serial and a progressive derecho explained, what did the numbers look like on June 29, 2012? Winds at the 850 millibar level were weak, ranging from 10 to 30 knots. The weak winds were directly related to the lack of a well-defined low-pressure system and trough, and the lack of strong winds within the jet stream. Winds at the 500 millibar level across the Ohio River Valley and the Mid-Atlantic ranged from 30 to 60 knots, with decent flow. Effective bulk shear was more than sufficient for storms to become an organized, long-lived line of storms. At 17 UTC, bulk shear was over 35 knots across the Ohio River Valley, with 40 plus knots of bulk shear downstream of the thunderstorm complex. So with adequate deep layer wind shear and flow, how unstable was the atmosphere? It was about as unstable as a Ryzen 7800X3D on an Asus motherboard. The atmosphere was a loaded gun that could allow for any small rain shower to expand and explode into a potent MCS and eventual derecho, assuming they could break through the cap. Surface-based cape was absurd, with the vast majority of the Midwest and Mid-Atlantic observing cape in excess of 2,000 joules per kilogram. Numerous areas observed cape in excess of 4,000 joules per kilogram, and a few areas observed cape in excess of 6,000 joules per kilogram. Convective inhibition, or the strength of the cap, was strong, especially on the surface, with the exception of portions of northern Iowa and Illinois, where the developing thunderstorm complex remained until it moved into Indiana and Ohio, where surface convective inhibition began to weaken throughout the day. Mixed layer cape was also absurd, with mixed layer cape frequently being above 3,000 joules per kilogram and reaching as high as 6,000 joules per kilogram. Convective inhibition at the 100 millibar level quickly eroded as the storms moved into Indiana. Mid-level lapse rates across the eastern United States were above 7 degrees Celsius per kilometer, with the majority of the eastern half of the country observing rates in excess of 8 degrees Celsius per kilometer. The mid-level lapse rates originated from an unstable air mass located above the Mojave Desert 60 hours prior to the derecho. Low-level lapse rates ranged from 7 to 8.5 degrees Celsius per kilometer. Surface temperatures were dangerously hot, with those underneath the Ring of Fire feeling like they were burning, with temperatures being in the mid to upper 90s and breaking into the triple digits come the afternoon and evening. The humidity was not helping, with dew points being in the 60s to 70s in the same areas, causing heat indices to be over 110 degrees Fahrenheit. The heat wave was long, and the potential was there for a strong MCS developing on the 29th. However, predicting the potential for what developed into the derecho was beyond difficult. The Day 3 forecast by the Storm Prediction Center on June 27th put a 5% probability ranging from South Dakota into the Ohio River Valley and the Northeast, with the forecast discussion stating that supercells would be possible, with convective development being confined to the frontal boundary. Deep layer shear was predicted to be 40 to 50 knots. NWS Wilmington put out a forecast discussion on the 27th, stating, if mid-level flow can erode capping, a high-end, damaging MCS event is possible, as the synoptic setup will be an ideal derecho-type environment with extreme instability on the edge of a cap and strong northwesterly mid-level flow. The Day 2 forecast put a general thunderstorm risk over the same areas, with a 5% probability being put in place. The threat was now expected to be more in line with a wind event, with the 6Z outlook mentioning that surface heating and low-level convergence could initiate isolated thunderstorm activity anywhere along the boundary. If storms could initiate despite the warm air aloft, moderate deep layer shear and steep low-level lapse rates would be enough for isolated wind damage. The 6Z Day 1 outlook had a slight risk over Iowa, Illinois, Wisconsin, Indiana, Michigan, and Ohio, with a 2% TOR and 15% wind and hail risk. The expectation was for a few clusters of strong to severe storms to develop in the afternoon and overnight hours within the corridor, but the problem came down to where storms would form, as the outlook stated that the foci for initiation appeared rather vague within the corridor, although the end of the paragraph notes that confidence was increasing regarding initiation in Iowa and northern Illinois. At the 13Z outlook, a 30% wind risk was introduced in Illinois, Indiana, and Ohio, with a 30% SIG hail risk being introduced as well. Convective evolution of the thunderstorms was still unclear, with the expectation that multiple storm clusters may develop and grow upscale into a forward propagating system, with the risk of damaging winds and large hail spreading across the slight risk. At the 1630Z outlook, there was still a fair degree of uncertainty on the convective evolution for the afternoon and into the night. SSEO guidance maintained the cluster through the Appalachian Mountains, while the NAM, not as strong, suggested that convection would fester for several hours over the Midwest. The expectation was that the severe threat would be limited to the west of the Appalachian Mountains. However, come the 20Z outlook and the 1Z outlook, when the storms had already developed into the derecho, a moderate risk was issued for Indiana, Ohio, West Virginia, and Pennsylvania at the 20Z outlook, and West Virginia, Maryland, and Virginia at the 1Z outlook. Progressive derechos are extremely hard to predict, and the SPC nor meteorologists expected the events of June 29th through the early morning hours of the 30th to pan out the way they did. It was an extremely conditional setup, and with the perfect cards in Mother Nature's hand, the worst-case scenario was about to unfold. The morning hours of June 29th were already hot across the eastern United States. Meteorologists across the Ohio River Valley and Mid-Atlantic made mention of the threat for severe storms later in the afternoon, but the public was focused on trying their best to escape from the deadly heat. Very few would have the idea of a potential windstorm on their minds, but Mother Nature had already begun playing her hand during the morning hours. During the early morning hours of the 29th, showers and thunderstorms moved into Iowa from Nebraska. However, those were not the original thunderstorms that are credited with the origins of the derecho. By sunrise, small, elevated thunderstorms formed in Iowa, and over the next few hours, traveled into Illinois. With the extreme lapse rates in Cape, the storms became drastically more organized come 9 a.m. Central, and at around 9:30 Central, the first severe thunderstorm warnings were issued for northern Illinois. The event was about to begin. The leading thunderstorm cells began to turn northward, splitting from the thunderstorms behind before moving eastward and then east-southeast. At 11:50 a.m., a severe thunderstorm watch was issued for northeastern Illinois, northern and central Indiana, and Lake Michigan. The primary threat was for very large hail and some strong winds. At the same time, the leading thunderstorms crossed over the Chicago metropolitan area and over portions of Lake Michigan, and Mother Nature would play her next hand by the MCS crossing over and near Lake Michigan. Lake Michigan was extremely important for the development of the derecho. Cooler air over Lake Michigan rushed inland, known as the lake breeze. The lake breeze caused warm, unstable air to rise rapidly across the Ohio River Valley, helping to fuel the storm system. Now, with the system moving into Indiana, the MCS was about to become stronger. As the storm complex moved into Indiana, severe thunderstorm warnings ceased from noon through 12:30 p.m. Central. Small cells developed to the south of the main cluster around 12:20 p.m., and those cells quickly grew upscale, converging and becoming part of the main MCS at 2 p.m. Central. But at that time, derecho characteristics were already being noted. Meanwhile, in Wilmington, Ohio, the NWS office released a special midday weather balloon to determine whether the atmosphere was still capped. The weather balloon sounding confirmed the worst-case scenario. The cap was weak, and the atmosphere was extremely unstable. Moving into Indiana, radar imagery observed winds over 70 miles per hour. While those winds were elevated, the winds intensified as they approached the KIWX radar site. Over the span of 2 hours, winds of 65 to 85 miles per hour developed within the line segment. Just before 3 p.m. Eastern, the line reached Fort Wayne. Many looked up in the sky to see the dark shelf cloud approaching the city. At the airport, a measured wind gust of 91 miles per hour was observed. Throughout Fort Wayne and the surrounding communities, trees crumbled due to the sheer force of the high winds. Power lines snapped and fell onto the ground, and transformers exploded. Doppler radar indicated that in Fort Wayne, winds in excess of hurricane force battered the city. After passing through the city, a well-defined bow echo shape was observed, a classic derecho indicator. Shortly after the line moved through Fort Wayne, a severe thunderstorm watch was issued for Ohio, far northern Kentucky, and into West Virginia, with a greater than 95% probability of 10 or more severe wind events. In Ohio, the derecho would begin to show its true ferocity. The derecho was now moving to the east-southeast, or southeast, at 60 miles per hour, a speed and trajectory that was maintained throughout the rest of its life. Winds across eastern Ohio were howling, with gusts reaching as high as over 100 miles per hour. At 3:15 p.m., a wind gust of 84 miles per hour was reported in Findlay. Radar showed velocity outbounds and inbounds converging into each other, resulting in a 70-knot mid-altitude radial convergence. 50 knots is usually enough to suggest strong surface winds within a squall line. The situation at hand was clear as day. An ongoing MCS had developed and had no signs of stopping. So, the SPC issued a moderate risk just after 3:30 p.m. Eastern. Around the same time, large hail was being reported out of Marion and Marysville, Ohio. As the derecho aimed itself towards the central parts of the state, a well-defined shelf cloud with an eerie green core behind it eclipsed across the skylines. Around 5 p.m. Eastern, the derecho crossed Columbus, causing extensive damage. Transformers began exploding left and right, knocking out power to the majority of the city. Winds in excess of 80 miles per hour were reported up and down the state. The derecho maintained its intensity as it crossed into Pennsylvania and West Virginia around 6:30 p.m. At that time, the storm system, contrary to what the SPC believed, was not slowing down as it marched into the Appalachian Mountains. Another severe thunderstorm watch was issued. At 7:17 p.m., the derecho crossed into Charleston, West Virginia, with a measured wind gust of 78 miles per hour being recorded. Radar imagery, however, was not reflective of the winds on the ground due to the sampling from the radar ranging from 5,000 to 10,000 feet in the air. Meanwhile, in Kentucky, along the southern edge of the derecho, an outflow boundary raced southward, causing wind gusts to plague the far northern portions of the state. At a home weather station near Williamson, a wind gust of 93 miles per hour was recorded at 7:42. Calls across the state of West Virginia confirmed that wind gusts ranging from 60 to 80 miles per hour were constant throughout the line of storms, despite what radar suggested at first glance. Around 9 p.m. Eastern, the derecho crossed into Virginia, with the intense winds still present and causing havoc. With the sun set, many would think the derecho would begin to weaken, but that was far from the truth. Even after sunset, the hot, humid air mass was still present, and Cape, while lower than it was earlier in the day, was still extremely high at 3,500 joules per kilogram. The failed weakening of the derecho led to the moderate risk being expanded once more to include the mid-Atlantic region. At 9:10 p.m., the Roanoke-Blacksburg Regional Airport measured a wind gust of 80.6 miles per hour, the highest wind gust ever measured at the site. Doppler radar confirmed that winds in excess of 70 knots were about to slam into Blacksburg, Virginia. At 9:30 p.m., the derecho had crossed over the Appalachian Mountains. In Berkeley County, West Virginia, radar reflectivity showed a rapidly expanding and congealing convective line as it came off the mountains, indicating strong updrafts. Winds near Berkeley County were well in excess of 60 miles per hour, with the strongest winds in excess of 70 miles per hour being observed in Martinsburg, where a renewed surge in the rear inflow jet slammed into the town. At 10:10 p.m., the SPC issued a final severe thunderstorm watch for Delaware, Maryland, Virginia, New Jersey, the Chesapeake Bay, and the mid-Atlantic coastal waters. The derecho began to rapidly intensify to the east of the Appalachians, as wind gusts in excess of 80 miles per hour blasted across the state of Virginia, with the city of Fairfax being slammed by those winds at 10:30 p.m. Just after 10:30 p.m., the derecho entered Washington, D.C., and showed no mercy, with winds as high as 80 miles per hour slamming the D.C. metro area and into Alexandria. Widespread winds were observed on radar as a sea of orange on velocity enveloped the city. After hitting D.C., the derecho began blasting eastern Maryland just after 11 p.m. More wind gusts of over 60 miles per hour were reported near the coastline, with radar continuing to confirm the violent nature of the derecho. The system crossed over into Salisbury, Maryland at 12:10 a.m. on June 30th, and further north into southern New Jersey at 1:11 a.m. The derecho was still ongoing, slamming Atlantic City and the coastline with intense winds. At the Atlantic City International Airport, a wind gust of 87 miles per hour was reported. At 2 a.m., the derecho moved over into the Atlantic Ocean and rapidly weakened, ending the 12 hours of violent winds across 700 miles. Unrelated to the actual derecho itself, the extreme heat broke numerous records before the storms themselves arrived. On the 29th, Athens, Georgia, and Columbia, South Carolina set their all-time record high temperatures at 113 degrees Fahrenheit. Washington, D.C. recorded its highest June temperature at 104 degrees Fahrenheit. All across the eastern half of the country, all-time heat records were being matched or broken. Tornadoes were not a major threat with the system, as there were only 2 tornado reports. Both were unconfirmed. The nature of progressive derechos tends to limit tornado development, at least in comparison to serial derechos. Although multiple tornado warnings were issued, the high winds with the derecho were dangerous enough for people to take similar precautions for when there was a tornado warning. Large hail was observed in portions of Illinois, Indiana, and Ohio, with the largest hail being 2.75 inches in diameter. Behind the main derecho, another MCS attempted to develop in Iowa and Illinois. However, due to the cold pool that the derecho had left behind, the MCS did not form into another derecho and remained mostly below severe limits. But for many across the Ohio River Valley and the Mid-Atlantic, they were now becoming familiar with what a derecho was, and the absolute chaos that it had created. Approximately 700 miles long, up to 60 miles wide. Up and down each state in the path, it looked like a massive tornado had swept across the states. Yet, there was no tornado. But instead, a derecho. For those along the derecho's path, it was one to remember. The effects in Iowa and Illinois were minimal, but it was as the system moved into Indiana when the damage path truly became obvious. The first major area hit was Fort Wayne. All across the city, power infrastructure was crippled, and residents came out of their homes after the winds died down to trees blown over onto their houses and across the land. The wind gust record of 91 miles per hour in Fort Wayne lasted for about 10 years until 2022, when another derecho brought winds of 98 miles per hour to the city. The state of Ohio was thrown into disarray by the extreme winds, with town after town and city after city being hit hard by the windstorm. First was Columbus Grove, where winds estimated to be over 100 miles per hour tore the city apart. Brick buildings had their walls blown out, the walls smashing onto the cars below. Findlay, Ohio, and Hancock County had more extensive damage. Trees and power lines were knocked down onto streets and households alike, a trend that continued throughout the derecho's path. In Bellefontaine, the courthouse clock tower, which was primarily made of sandstone, was severely damaged, and the base of the tower was twisted. The tower was disassembled and repaired. A building in Marysville, Ohio, partially collapsed, and was later demolished. Power poles were slammed onto the pavement, and large trees were snapped off or uprooted in Columbus, Ohio. Barns were destroyed and torn into pieces. Windows were blown out in Cambridge and Byesville, Ohio. In Ohio alone, over 1 million customers lost power, with power outages being widespread across roughly 2/3 of the state. The damage to the power grid in the state was worse than the damage caused by Hurricane Ike in 2008 as a tropical storm. The damage to the power grid and the widespread damages across the state led to Governor John Kasich declaring a state of emergency. In Ellenboro, West Virginia, a transmission tower was destroyed, bent over, and toppled onto the ground below. At Yeager Airport in Charleston, the hangar was damaged, and a small, single-engine plane was flipped on the tarmac. Trees across West Virginia caused damages to homes, vehicles, and infrastructure. An estimated 670,000 customers in West Virginia lost power. Trees in excess of 3 feet in diameter were uprooted across portions of Kentucky. The numerous trees falling caused havoc into Virginia, damaging structures and flattening cars. In Maryland, a plane was flipped at the Tipton Airport, and the South Jersey coast was left with trees and power lines littering roadways. It was like nothing the Mid-Atlantic had seen before. The 2012 derecho was the first well-known derecho outside of the plains in the Deep South because of the number of population centers in the Mid-Atlantic that had not been impacted by a derecho of such intensity in recent memory at the time, and the damages it had caused. The Mid-Atlantic had been subject to derechos before, such as in 2008, but the 2012 derecho was stronger, and knocked out power to many areas for longer than in 2008. In total, 1,195 wind reports were filed on the 29th, with 37 reports being for winds in excess of 74 miles per hour. The storms caused 22 direct deaths, one of the higher death tolls from a derecho in US history. But the deaths did not stop there. During the aftermath of the event, over 4 million customers were without power from Indiana through the mid-Atlantic coastline, and the heat wave was not going away anytime soon. What followed was an additional 34 deaths being related to heat-related illnesses in locations where the derecho knocked out power, where it was out for over a week in some locations. The derecho caused $2.9 billion in damages in 2012, becoming the costliest derecho in US history until the August 2020 derecho. However, the media and several others on the ground who were unaware of the storm system being a major threat until it was knocking on their doorsteps had several questions after the fact. Most notably, why was the event so poorly forecasted? Across news agencies following the derecho, one sentiment was clear as day across those who were writing up articles or doing interviews. The event was poorly forecasted, by a significant margin. Not only was it poorly forecasted, but public sentiment reflected that they didn't feel like it needed to be taken seriously until it was right in front of their faces. Many had little idea what a derecho was in the mid-Atlantic. That was a well-known fact after the event had occurred. However, for the National Weather Service, the Storm Prediction Center, and broadcast meteorologists, something went wrong regarding how the event was forecasted and how the public interpreted the messaging. In 2013, the Service Assessment Report was released by the Department of Commerce, and it had multiple interesting findings. So, how did the public respond according to the report? Surveys were conducted in Ohio and Virginia, asking participants about how they received warnings, what they did when the warnings were issued, the effectiveness of the warnings, and the perceptions about severe thunderstorm warnings. The results suggested that the primary means of receiving warnings was from television. Severe thunderstorm warnings do not typically trigger an immediate response. Participants believed that there was inadequate warning, and many said that they would react differently the next time a warning for a similar event was issued. The report states that the NWS's wording regarding warnings were acceptable, with some critiques about the coordination between the NWS offices and the SPC regarding the issuance of severe thunderstorm watches. So what went wrong? The forecast. Forecasters at both the SPC and the NWS rely heavily on the National Centers for Environmental Prediction, or the NCEP operational models to forecast thunderstorms. If models such as the NAM or GFS show a strong signal that thunderstorms will develop, forecaster confidence is increased. Generally, they are looking for a coherent precipitation area generated by the models that persists, and, in the case of a derecho, moves downstream. For the event in question, both the GFS and the NAM did not show precipitation for the time the derecho was occurring. Therefore, those models were of little use to predict and forecast a derecho. The lack of a signal in the NCEP models from 3 days prior right up until the event occurred impacted the preparation and content of forecasts, outlooks, and decision support. But not all models showed nothing. On the day of the event, some of the high-resolution convection allowing models, the CAMs, that could explicitly simulate some aspects of thunderstorms showed signs an MCS would develop and move across the areas later affected. One of those was the experimental HRRR model, which showed a strong bow echo moving across the Ohio River Valley. However, forecasters were suspicious of the model because of past erratic performances and the lack of a signal from the GFS and NAM. Some WFOs were using the HRRR, but understanding the model was hit or miss depending on the office. The recommendations from the report regarding the performance of the forecast were as follows. The NWS should invest in infrastructure that would provide the computational resources to operationally run the CAMs, with the Environmental Modeling Center needing to develop a fully supported ensemble of high-resolution convection-allowing models that cover the Day 2 outlook. WFOs should add training to forecasters to help them understand high-resolution models, and the SPC and NWS offices should work together about issuing watches more effectively. However, blaming the Storm Prediction Center and National Weather Service directly for the forecast not being representative of the final result is not what I'm trying to do here. I'm simply trying to explain the sentiment that I observed from when I was looking through resources on the subject, and felt like it needed to be covered. Considering it was 2012 and the nature of computer models and forecasting progressive derecho events, from someone who studies meteorology, it's understandable as to why the SPC didn't go full Broyles mode, as some people say. The confidence just wasn't there. For the general public, on the other hand, they likely don't know just how much goes into the forecasting side of things at places such as the Storm Prediction Center. Rich Thompson mentioned it when I covered December 10th. It seems so much easier to make a forecast when you already know the outcome in retrospect. But there's also personal responsibility here. It's not the SPC's job to force people to take action. That much needs to be made clear as well. Since then, weather models have gotten much better regarding how reliable they are for forecasting severe weather events, but systems like progressive derechos are still difficult to forecast. On June 29, 2012, the mass media and general public became familiar for one of the first times with the term derecho. A 60-mile wide storm complex moving at 60 miles per hour from Indiana through the mid-Atlantic coastline. Along the derecho's journey, many came familiar with the powerful winds they bring, as up and down its path, trees fell, and structures were severely damaged. With billions of dollars in damages, and multiple deaths attributed to the storm complex, there are numerous reasons as to why the derecho is remembered so infamously. To many across the mid-Atlantic and Ohio River Valley, no other derecho comes close, with many comparing the damage and winds to that of a hurricane. It was a severe weather complex that none of those in the portions of the mid-Atlantic had ever seen before, at least at that intensity. Its memorability in the mainstream media led to the term derecho to be more well known across the United States as a whole. The problems the Storm Prediction Center and the National Weather Service had forecasting the event was also a major problem that many remember. The poor forecasting of the event was something that many remember to this day, and looking at how it verified in comparison to the first day one outlook, it's easy to see why, at least from an outsider perspective. Since then, the HRRR became operational, and many improvements to how the NWS and SPC handle events like the 2012 derecho have been made. The 2012 Ring of FIre Derecho is an event that many will not forget, and it's one I will not forget anytime soon. Special thanks to my proofreaders, those being Nora, Neptune, Broker, and Rishi. Serious props to them for making me not sound like an idiot. Celtic White for the character stills I use, Zinel, Cyanide Blue, and Crackleck for letting me use their music when I use their music in my videos, and everyone for watching, it means a lot. I also want to give special thanks to Ace Cooper, who is someone who I've talked to a lot, really good friends with them, for letting me use his footage from the derecho in West Virginia. Special thanks to those who are subscribed to the Patreon or are a YouTube member. Those being Ace Cooper, Ambiguity, Montpelier, Tanner Lepper, That Dude, and Von Guros at the Alfie's Army tier, Helldrake Zero and Tennille's Weather Marine Space Station at the Alf Jr. tier, and Basilius of Stupidonia, Ed Taylor, Epix, Hannah Stormer, Jay Cario, King Shisha, Neon Binary, Sandra Dunn West, Talkboy, Van Granny, and Worm Off the String at the Alf Midi tier. If you want to have access to full uncut interviews and my scripts alongside other things in the future, consider subscribing to the Patreon or becoming a member. It helps me financially and will allow me to do in-person interviews in the future, hopefully. Anyways, that covers everything. If you enjoy what I do, consider liking, subscribing to the channel, commenting your thoughts, and sharing it around, all that jazz. I'm Alferia, you all stay safe, and I'll see you all soon.